All right, here we go. We got the beginning of distance and midpoint formulas. But before we get back into distance, we've kind of done that maybe a couple of days ago here. Remember, for distance, if you just have 2 points on just any given line, you can just go and take the difference between those 2 points, and then you do the absolute value. And I think that was on lesson 1.3, if I recall correctly here. And then later on here into the lesson, we're going to get into finding the distance between 2 points on a grid, kind of like that. But this one right here, find the distance between A and B on a number line. If A is at -3, B is at 7. So I'm just going to quickly do, it's -3, you subtract the 2. If your answer is negative, you do the absolute value of that and just make it into a positive number. -3 minus 7 right there, that should be -10. But then we're going to absolute value that. That should be 10. And then I guess they didn't really give us any units, so I'll just say 10 units long. And that's it right there. Now what's a little bit different today here, so we're also going to talk about how to find a fractional distance. And it's really not too challenging, honestly. But let's look here, the coordinates of point E. Find the coordinates of point E if E is 1/5 of the distance from A to B. I'm just going to sketch a quick picture real quick. So apparently here's A, here's B. E is 1/5 of the distance from A to B. So I guess this point E is somewhere over here, maybe a little bit closer to A since it's only 1/5 of the distance from A to B. So what we're going to need to do is actually find that same distance. I guess we're assuming this is the same number line. So A is at -3, B is at 7. Okay. And then we'll do that same thing again. If you want to rewrite it again, you can. You don't necessarily have to. I'm just going to skip and put that as 10 right there. So then to find this fractional distance, now the new part here is we're going to take this fraction here. We're going 1/5 of the distance. We're going to do 10 times the fraction 1/5. All right, depending on how good you are with fractions, you can use all your rules right there. Essentially, that just means we need to go and do 10 divided by 5 right there. So that should come out to 2 units. All right, but then 2 units isn't necessarily the answer. 2 would be probably a little bit closer over here. But we're 2 units away from E. So this distance right here is 2 units. So then to go find where E truly is, we're going to take the -3. We're going to take point A. We're going to add on the distance right there. And then that's going to get us our new point E. And here I'll label this as a E. So E will be -3. We add that distance. That'll come out to -1. So E is at -1 right there. That is that distance right there. And we got an extra example here just to kind of hit it home here. So think about this here. Let's use that same number line here. What about point D? D is on, it's 7/10 of the distance from A to B. Right here. It's a terrible looking arrow. Let's see if we get that looking better. I'm trying this Apple pen, so it's a little bit new for me. Okay. So yeah, point E now is over here, a little bit different. 7/10 from A to B. So notice, yeah, we're going from A to B. So this 7/10 distance needs to be right there. All right, I actually probably wouldn't write that, but same thing. We'll get the distance, so we know, AB was 10, just like from the previous one there. So then we're going to go and kind of do what we did up here, except instead of multiplying the distance 10 by 1/5, now we're going to multiply by 7/10. All right, and if you kind of think back to middle school, you could write that as 10/1. You could say, hey, the 10s reduce, and then it's 1 times 7, which is 7. 1 times 1 in the denominator would just be 1, which means it's going to be 7 units away. Okay, and then the final part here, we go take that 7 units and we add it on to point A, kind of like what we did before. We had -7 or -3 and 7. And then so I'm going to go take -3. We're going to add on the 7 units. Comes out to 4. So that's where E is at. E is at 4. That's like its location there. Okay. And then now what we're going to do here is talk about how to find what we call the midpoint. And there's two approaches here. I'm actually going to kind of use the above method right here for these two right here. I guess we don't have them numbered, but these two problems right here, we'll use that same method, and then I'll show you maybe a shorter way to do that, maybe especially you got bigger numbers going on here. So the midpoint is halfway. So we wanted to go and take that distance of 10, and we want to go halfway. So we'll go 1/2 of that right there. That should be 5 units. 5 units away. Let's try to spell, all right? And then we'll take that -3, that point A, and then we'll add on that 5 to it. That should be at 2 right there. So that's where your midpoint should be located. Now another thing that we can do here, instead of doing that, is the midpoint is, all it is an average. It's an average of your 2 points. And remember, to average something, really you just need to go take the two things that you're averaging and then add them up, divide by 2. So let's go and take -3 and let's go take 7. Those are our two endpoints here, especially if you're looking here at your previous picture. Add them up, divide by 2. That should get you your midpoint. And hopefully if we did it right, it comes out to the same thing. So -3 plus 7, that should be 4. 4 divided by 2 should be 2. That would be where your midpoint is. To me, I think the average is a little bit quicker, especially once you kind of grasp it, but you can do it either way right there. Okay, now this next part here, the idea of calculating distance and midpoints is very similar on a coordinate plane, except you have 2 dimensions to take into account. You have your x and your y dimensions. So this is kind of, I guess, doing it in a plane right here. So let's look at the distance between the points -1, 3 and 5, 6. Oh, these numbers are throwing me off. 1, 2, 6. Okay. Yeah, it kind of threw me off there because the numbers were in weird spots. Okay. So anyways, there's your line right there, and we're going to find the distance of that line. Now, unfortunately, we can't just go and count, units, say, okay, it's, 1, 2, 3, 4, 5, 6 units over or whatever we think it is there, because we have 2 dimensions to it. Okay, but one thing that we're going to do, this is one of the ways we can go and find the distance here, is we're going to make a triangle, and we're going to use this line, this diagonal line, we're going to use that as a hypotenuse of our triangle. Okay, because this is a very specific triangle. This is a right triangle. And what we learned from middle school is that if we can use the Pythagorean Theorem, the a squared plus b squared equals c squared, if we learn that and use that right here, we can go and find this distance c, whatever it is. So let's count how many units over we are for a. Here you got 1, 2, 3, 4, 5, 6 units over. Let me make that look a little bit prettier. Right over here, you got 3 units going on right there. So then we're going to go and say, okay, 6 squared plus 3 squared, and then equals your c squared. Okay, so you got something like 36, you got plus 9 equals c squared, something like 45 equals c squared, and then we're going to square root both sides. C is the square root of 45. Now, if you watch my other video, I think it was the very first one where we barely talked about finding, I guess, simplifying down this square root of 45. If you don't remember that, you can go search it on Google or ask one of your teachers in class. It's really not that hard. I'm going to do this example real quick here. So you basically make a factor tree, figure out what this thing breaks down to, and then you're looking for groups of 2. You're looking for pairs. Right? So since we have one pair of 3s, we're going to write that outside the radical. And then this 5 doesn't have any pairs, so that stays inside of our radical. So we're going to say that distance c, or I guess if you want to call it d for distance there, we're going to say that's 3 square root of 5 units right there. Okay, and that is one of the ways there to find your distance. So this is actually, someone derived a formula. It's really not that hard as far as the formula goes here. So this is the distance formula, and you need to memorize that. That'll be really helpful there if you do. So let me talk about where the different pieces here. You have the x2 minus x1 right there, and that's talking about your different x coordinates. So if we go back up here to the top here, let's label these points. It was -1, 3, and then you had 5, 6. So your different x values are -1 and 5. And what this is saying here is to take your two x values and do the difference, just like on that very first problem when we're finding just, one-dimensional difference there. We take them and we subtract them. Okay, now you do the same exact thing for your y values. So notice here we had the 6 and we had the 3. We did the difference there. We counted up. We said that was 3 units. That's this next part right here. Okay, now what the Pythagorean Theorem says is we need to do a squared plus b squared. But the whole idea of your distance formula, notice it's a little bit different here. You're squaring some stuff, but you got to go and actually calculate that x minus x distance and that y minus y distance. And then to cancel out your square root, or I'm sorry, your square on the d right there, we got to square root both sides there, and that's where the square root comes from there. Okay, so that's where it's derived from. Do you need to know that? Not necessarily. I just wanted to show you the connection there. Key thing too is these 1s and 2s. Actually, I usually tell my students to blot them out because the order doesn't necessarily matter, and that's because of the squared. So like for example, if we went back and used that previous example when we did 6, or actually I think it was 5 minus -1, that would have gotten us 6 squared. Now if I went off to the side and I did it in the opposite order, and I did -1 minus 5, but then I squared that answer, that's -6 squared. But anytime you square a negative, it becomes a positive anyways. So that's why I say to scratch out the numbers there, the x1, the x2. It does not matter what order you subtract them in. Okay, so that's your distance formula. Now the midpoint formula, there's a formula instead of a process. The process that we did on this second part right here, we kind of just used logic. We took our distance, we divided it by 2, and then we actually went that distance. Now it's a little bit more challenging when you're on, a coordinate plane right there. It's kind of hard to find exactly where the midpoint is. We can maybe estimate where it is, but that's where the formula is very helpful. And I don't really think about a formula. I think of a process, and this process is just an average. You're going to average your x, and then you're going to average your y. Okay, and that's what this stuff is. To do an average, you take two things, and you add them up, and then divide by 2. If you had 3 things, you'd add 3 things up, and then divide by 3. So take your 2x values, since there's 2 of them, add them, and then divide by 2. Take your y's, add them up, divide by 2. Notice that this is in the format of an ordered pair. It should be some type of x, comma, y. Okay. Now, some people kind of learn about it like separate like that, I guess. I mean, it's essentially the same thing. It's not really different there. All right, so these next few examples here, we're going to go ahead and actually apply the distance and the midpoints of these segments that we have. Right, they're asking us to find AB. When they're asking us to find AB, this is implied. They're asking us for the distance right here. So we're going to use our distance formula. Remember, it doesn't matter on the order of like what you call x1 and y1. I don't even really label it x1 and y1. I just label them x and y, x, y. All right, and then I guess I'll go the first one here. I'll go 2 minus this other x right here. I'll color code it here for you. So 2 minus -4, and then we'll square that. And then we're going to go 4 minus 12. And actually, we need to add first. So we'll add parentheses 4 minus 12 and squared. Okay, and now 2 minus -4 minus a negative, that should change to a positive. So it's kind of like 2 plus 4. That should get us 6. And we're going to square that. Now over here, this little blue part right here, 4 minus 12 right there, that'll be -8. And here's why the order doesn't matter once again. Once you square something that is negative, it becomes positive. So if these were swapped around right here, that would have gotten us +8, but still squaring +8 should have gotten us the same thing there. So Then, sorry, no, this kind of looks like a mess here because it's different colors, but the first one, 6 squared, that'd be 36. 8, or negative 8 squared should be 64. And then that adds up to 100. Now, this actually happens to be a perfect square, so unlike that last one on the previous page where it broke down the radical, here the square root of 100 is just regular 10. You can still do the factor trees if you want. Just when you break it down all the way, you're not going to have anything left over. And you'll have 2 pairs on the outside. So anyways, we know that's going to be 10, so we'll just call that good right there. Okay, now this next one here says find the midpoint of AB using those same 2 points right there. So actually, I'm going to keep it color-coded here. So I got the 2 x's, or 2 and negative 4. We already talked about this being an average, so make sure we do the average of these here. So we'll go 2 plus negative 4 divided by 2. That'll be your x piece. If you want to go ahead and throw it into an order pair format where you got, your first number, comma, and then your second number, you can. Okay, our 2 y values, 4 and 12. So we'll just go 4 plus 12, and then we'll divide that by 2. I'll go ahead and do that since I'm already in that color. 4 plus 12, 16. 16 divided by 2, that should be 8. Okay. And then this 2 plus negative 4, that would be negative 2. Negative 2 divided by 2 will actually get us negative 1. And there is our ordered pair right there. Negative 1, comma 8. That is the midpoint of this segment here, AB. Distance formula again. Distance formula, take your x's. I'm going to do the other order now. I'm going to do, what did I do? I did 2 minus negative 1, so I'm going to go in the other order. I'm going to go the second point here minus the first point. So we'll go 1 minus negative 2 squared, and then plus, and then we'll go 0 minus 3 squared. Okay, so I'm getting 3 squared. I'm getting negative 3 squared on this other one. Both of those will both come out to 9. So that means that this is equal to the square root of 18. Okay, and then we'll break down the radical. You got 9, 2, 3, and 3. Got a group of 3's and then 1, 2 left over. So we'll say 3 square root of 2 for your exact answer. Once again, if you want the decimal, it's just typing it into your calculator. So that should be straightforward. Okay. Next, we got the midpoint. So we'll go our x's first. Negative 2 plus 1. Remember, it's an average, so then go back and divide that by 2. Guess we're probably going to get another fraction again. That's all right. The other one was 0 plus 3, and then divided by 2. So that's 1 half, and that's 3 halves right there. And actually, you know what? That's negative 1 half, so my bad on that. Not subtracting right. So that's your midpoint. Sometimes they'll use an M to label your midpoint. I didn't do that on the last one, but most of the times that's what they'll do. There. So that's it on that one there. So we'll move along here. What do we got here? Given the point A, negative 2, 4, and M, negative 7, 6, the midpoint of AB, find the coordinates of point B, and then find the length. This means the length of AB. So this one's a little different here. We're going to put a star next to this one, and that's because they gave us the midpoint. So that's a little bit different there. So they're giving us the final answer. So whenever we average our x's, we're going to have something plus this other x value divided by 2 equals negative 7. And then the same exact thing for the 6. We have the 6. We're going to have 4 plus some number divided by 2 is going to get us 6. So whenever I'm working backwards at all, I like to think of algebra. So this other point, I guess we'll call it B. I'm just going to call it x comma y for right now. So I'm going to go and I'm going to use the midpoint formula, the midpoint process. I'm going to say x plus negative 2. Whatever that is, I'm going to divide that by 2. And then it gets me this answer of negative 7 for the x coordinate of the midpoint. So essentially I'm kind of thinking backwards in a way, I guess. So I'm going to get rid of that divide by 2, we'll multiply by 2 on both sides. So therefore, those fractions cancel there. You're left with the x minus 2, or plus and negatives is, the same thing as minus. So then we got negative 14 right there. then we'll add negative 2, so I think you get negative 12. And that is for the x coordinate of the other end point. So now we're going to do the same exact thing, but we're going to do it with y's. So we know the final answer, the midpoint of the y, or I'm sorry, the y of the midpoint, I guess I should say, is going to get a 6. We're going to have something equals 6. And what is that going to be? It's going to be y plus 4 divided by 2. Okay, so then we'll multiply by 2 on both sides. The 2's cancel out. You got y plus 4, and then you got equals 12 on the other side. And then we'll just subtract over 4, or subtract 4 from both sides, and then we'll get 8. So that means if we slap these together, we have the other endpoint. The point B is going to be the order pair negative 12 and then comma 8. And I'll show you a more visual way here in a second once we find the distance of AB. So after this here, find the distance AB. So we'll do that. A to B, so here's your A point, here's your B point, and we're going distance formula there. We'll go negative 12 minus negative 2, so I'm going to put plus 2. I'm going to simplify that one step there quickly. So remember, minus and negative turns to the plus. Other one, 8 minus, where are we, 4. Okay, and then we're going to square that. And I think I'm getting negative 10 squared, and then we're getting 4 squared. And that's 116. And then let's see if that thing breaks down. So 116, you can go off to the side with your factor trees. We're going to have, let's see, I guess 4, and I believe it's going to be 29. All right, and then the 4 breaks down to 2 in the 2. And then, yeah, so we got 2 squared at 29. Believe it or not, that is simplified. I can't really simplify down that radical there anymore. Okay, now I'm going to go ahead and erase this stuff up here at the top so I have room to work it. I'm going to show you a more visual way to find the endpoint given the midpoint. So sometimes I tell people to sketch out kind of maybe what the line maybe would look like. And I put this point here, negative 2 comma 4. That's A. And then we're going to put the point here, M. And then we're going to say that's negative 7 comma 6. And then we'll put B over here. And that's X comma Y. And this is more of a visual and then just using logic, I guess, here. So what I'm going to do here is to get from negative 2 to negative 7, and I know I have this kind of backwards here. It looks like we're going to have to subtract 5. So that means to get from negative 7 to your x value, you're going to have to subtract 5 again from the negative 7, and that's where the negative 12 comes from. Now you can do the same thinking for your y values as well. To go from 4 to 6, we got to add 2. So to go from 6 to the next y, we got to add 2 again. And that gets us 8 right there. So 12 comma 8, negative 12 comma 8. Notice you get the same thing. It's 2 different ways. And honestly, I don't personally care which way you do it. One's more visual, one's more algebraic, Okay. Let's see here. On a number line, point A is at negative 3, and then point B is at 5. What's the midpoint? So now that we know the midpoint process, we can just quickly go do an average instead of like what we did at the very beginning here. We found the distance and did half the distance from one of the endpoints. Now we can just go and straight up do an average, and it makes it a lot quicker. So we can go negative 3 plus 5 divided by 2, and since it's one-dimensional, you only have one of these. So that'll be 2 over 2, oh whoops, I'm sorry. 2 over 2, I said it, and then that'll reduce to 1 on a number line. Okay, let's see what this next one here. On a number line, point F is at negative 6 and G is at negative 10. Find the midpoint of FG. So same thing, different numbers. Take negative 6 plus negative 10, add them up, divide by 2. That's negative 16 over 2. That's negative 8 once you simplify. Okay. Next problem here. This is actually kind of a review problem from 1.2 with the segment addition postulate stuff. Notice K is the midpoint, so that means these two segments are congruent. So we can go 8 minus 3x equals 2x plus 5. Okay. The reason we do that, if we have a midpoint, JK is congruent to KL. Therefore, those algebraic expressions are equal. All right, and then we can go and get x by itself. We can go add 3x to both sides. We can go subtract 5 from both sides as well. That's getting us 3 right there. So then when we divide, I guess we're not going to get a clean number here. We're going to get 3/5. Now, if you want to use a decimal or a fraction or whatever, you can definitely go and do that. You can go do 3/5. That'd be 0.6. So you could plug that in, and it'd be pretty straightforward for the most part. But I guess we need to go plug it back in and then find the length of KL. So if we're finding KL, I'm going to go plug it into that one right there. So we'll go 2 times 3/5 and plus 5. And if you need some review on multiplying fractions, you can probably find some videos on that. I'm going to quickly do that here. You got 6 over 5 once you multiply these two fractions together. But then we got to add 5. All right. And I'm going to write it, instead of 5, I'm going to write it as 5 over 1. And actually, I'm going to move this as well so we can have kind of some type of logical order. So I guess we're going this way. Probably not the best, but oh well. Now, to add or subtract fractions, we need a common denominator. So we need to make that 1 look like a 5. And some of you guys remember, you just do 5 over 5 for that. You just multiply by whatever the other denominator is. So that'll be 6 over 5, and then plus 25 over 5. And then once you add everything up, that's equal to 31 over 5. And sorry for going from right to left on that one there. Not enough room on that. So that is 31 over 5. That is KL. Okay, you can also change it to an a mixed fraction if you would like as well. But most of the times we're going to accept that answer. Okay, last one, I guess, kind of a word problem. I mean, they give us a graph here, and I guess these are streets. The streets make a triangle. Find the distance and the midpoint between Parker and Elm. So here's Parker and then Elm Street right there. Then we're going to use the distance formula to find that distance. Now you can do two things. You can use the Pythagorean Theorem like we did on that first problem, or you can use the distance formula. Now, since we're kind of talking about the distance formula and we probably know how to do Pythagorean Theorem, I want us to think about it, or at least I'm going to do this in the notes, as a distance formula using the ordered pairs. And what do we got here? 4, 1. And we'll do the distance formula. So that would be 0 minus 4 squared. And then that would be 1 minus 4 squared. Okay, something like we get 4 squared here. We're going to get negative 3 squared, but when we square that, that's going to clean itself up. Here, I guess we'll put 16, whoops, and then 9, and then that's the square root of 25. Now, this one actually came out nice because the square root of 25 is an actual nice number there. That's 5 for your distance. So we're good on that one right there. That was nice. So that distance is 5. I guess you could slide it in right there. D equals 5. Okay, midpoint. So remember, you're just averaging your x's. So your two x's is 0, 4. So 0 plus 4 divided by 2. So that x coordinate is going to be 2. And the other one's 4 and 1. So 4 plus 1 divided by 2. So that's 5 halves. Or you could do, 2.5. So I'm kind of speeding it up there, but if you need to go back and check out, you need to go slower, you can check out, you can rewind the video. All right, let's see what this other order pair is, because I think we're going to need it here. We're going to need negative 3, negative 5. All right, and let's see here. Find the distance. and the midpoint between Maple and Parker. Okay, so that's these two right here. Once again, you can go and use Pythagorean Theorem. We're going to use distance formula, though. So I'm going to do the distance formula over here on this side so I can see the ordered pairs. That'll help me out. So -3 minus 4. And then -5 minus 1. Oh, I don't need a comma there. Okay, cool. So then that would be -7 squared. And then this other one would be -6 squared. So what was that? 49. And then plus 36. Okay, and that is going to get us 85. And then actually that doesn't break down, I believe. Yeah, because you're going to have like 5 and 17, I think. I believe it would be 5 and 17. You can't break down your 17. So the distance is the square root of 85. Now, I do have it written in my notes here that that's approximately 9.22. So if you wanted that, you could have it. Okay, and then last but not least, we need to do the midpoint formula. So 4 plus -3, or 4 minus 3. So that's 1 and then over 2, and that's already reduced for us, so that's nice. And then the other one is 1 and -5, so we'll go 1 minus 5, divide by 2, and then what was that, -4 over 2, so that'd be -2 once you get it done. And then there you go. So that would be your midpoint. If you wanted to, you could go plot them too. They didn't ask us to. But we could go and verify, see if it looks like it's at the midpoint. So there's 1/2, half a tick, and then down -2, and that looks pretty close to halfway there. So that does indeed look like the midpoint. Now this next section, I can't really do this on the iPad with the constructions there, so you're going to have to go over that with your teachers. There are plenty of websites where you can go. You can it'll teach you how to practice drawing a circle with a compass. But the big things that we're going to be doing is doing segment bisectors and angle bisectors. Now just to define them, just so we have for our notes, segment bisector, this is a line that bisects or cuts in half, I guess, a segment, I guess. And then you could probably even add into 2 equal parts, but that's what we're kind of referring to as far as it cuts in half. Angle bisector, it's kind of the same thing. Typically an angle bisector, usually we draw them as rays, but I guess you would do a line, I'm not quite sure, it just depends on your teacher. So we'll say the ray that cuts an angle in half. And that's an angle bisector. It kind of looks like this, and then you'll mark them congruent, but you'll need your compass for these steps here. So go ahead and make sure or actually it's on this next page. Yeah, it's on this next page here. So make sure you go check out some good videos for that. And that is it for today.